What is magnetism? Magnetism is the phenomenon arising from magnetic fields, which are generated by moving electric charges and intrinsic properties of elementary particles, like electron spin. These fields exert forces on other moving charges and on magnetic materials, causing attraction or repulsion without direct contact too. Classical laws of magnetism. Magnets always have two poles, north and south, and these poles cannot be isolated. They always occur in pairs. No magnetic monopoles exist. Like poles repel each other, and unlike poles attract each other. This attraction or repulsion underlies devices like compasses and magnetic clamps. The force between two magnetic poles is directly proportional to the product of their pole strengths and inversely proportional to the square of the distance between them, an inverse square law. Magnetic field lines represent both the direction and strength of a magnet's influence. They emerge from the North Pole, loop through space, and return to the South Pole. These lines never cross and always form closed loops, reflecting the continuous nature of magnetic flux 3. Fundamental electromagnetic laws. Gauss's law for magnetism states that the net magnetic flux through any closed surface is zero, mathematically expressed as nabla.b equals 0. This encapsulates the absence of isolated magnetic charges and the fact that field lines are continuous loops. The Lorentz force law describes the force on a moving point charge q with velocity v in a magnetic field. B, F equals q times cross b. This force is always perpendicular to both v and b, deflecting the charge without changing its speed. A current-carrying conductor in a magnetic field experiences a force given by F equals ILB sin theta, where I is the current, L is the wire's length in the field, B is the field strength, and theta is the angle between the current direction and B. Beyond the basics, you might also be curious about how magnetism underpins electric motors, generators, and transformers. The classification of magnetic materials, diamagnetic, paramagnetic, ferromagnetic, antiferromagnetic, and why only some materials become permanent magnets. Earth's magnetosphere, its role in shielding us from solar wind, and the phenomenon of magnetic pole reversals. Advanced topics like magnetic resonance imaging, MRI, spintronics, and the ongoing search for magnetic monopoles in particle physics.